Determine whether each function is even, odd, or neither. Remember that the function y equals f of x is even when f of negative x equals f of x for each x in the domain of f. And a function y equals f of x is odd when f of negative x equals negative f of x for each x in the domain of f. Part A. F of x equals 3x. Substitute negative x for x. 3 times negative x can be written as negative 3x. Substituting f of x for 3x, you find that f of negative x equals negative f of x. Because f of negative x equals negative f of x, the function is odd. Part B. G of x equals 2x squared minus 6. Again, substitute negative x for x. The quantity negative x squared simplifies to x squared. Substituting g of x for 2x squared minus 6, you find that g of negative x equals g of x. Because g of negative x equals g of x, the function is even. Part C. H of x equals 3x squared minus 2x plus 4. Again, substitute negative x for x. The quantity negative x squared simplifies to x squared, and negative 2 times negative x is positive 2x. Because h of negative x does not equal h of x, and h of negative x does not equal negative h of x, the function is neither even nor odd. Graph g of x equals 1/2 times the quantity x plus 2 squared. Compare the graph to the graph of f of x equals x squared. Notice that g of x is of the form y equals a times the quantity x minus h squared. Rewrite the function to identify a and h. Here a is 1/2 and h is negative 2. Because h is negative 2, the axis of symmetry is x equals negative 2. So graph the axis of symmetry along the line x equals negative 2. Also, because h equals negative 2, the vertex is at negative 2, 0. So plot the vertex at negative 2, 0. Now you want to find and plot 2 more points on the graph. Choose 2 x values less than the x-coordinate of the vertex. Then find g of x for each x value. When x equals negative 6, g of negative 6 equals 1/2 times the quantity negative 6 plus 2 squared, which simplifies to 8. So plot the point negative 6, 8. When x equals negative 4, g of negative 4 equals 1/2 times the quantity negative 4 plus 2 squared, which simplifies to 2. So plot the point negative 4, 2. Now you want to reflect these points in the axis of symmetry. So plot 1, 8 and 0, 2. Then draw a smooth curve through the points. Now you want to compare the graph to the graph of f of x equals x squared. Both graphs open up. The graph of g is wider than the graph of f. The axis of symmetry x equals -2 and the vertex -2, 0 of the graph of G are 2 units to the left of the axis of symmetry x equals 0 and the vertex 0, 0 of the graph of f. Graph g of x equals -3 times the quantity x plus 2 squared plus 2. Compare the graph to the graph of f of x equals x squared. Notice that g is of the form y equals a times the quantity x minus h squared plus k. Rewrite the function to identify the constants. Here a is -3, h is -2, and k is 2. Because h is -2, the axis of symmetry is x equals -2, so graph the axis of symmetry along the line x equals -2. Because h is -2 and k is 2, the vertex is at -2, 2, so plot the vertex at -2, 2. Now you want to find and plot 2 more points on the graph. To do this, choose 2 x values less than the x-coordinate of the vertex, then find g of x for each x value. When x equals -4, g of -4 equals -3 times the quantity -4 plus 2 squared plus 2, which simplifies to -10, so plot the point -4, -10. When x equals -3, g of -3 equals -3 times the quantity -3 plus 2 squared plus 2, which simplifies to -1, so plot the point -3, -1. Now you want to reflect these points in the axis of symmetry. So plot 0, -10 and -1, -1. Then draw a smooth curve through the points. Now you want to compare the graph of g to the graph of f of x equals x squared. The graph of g opens down and is narrower than the graph of f. The vertex of the graph of g, -2, 2, is 2 units to the left and 2 units up from the vertex of the graph of f, 0, 0. So the graph of g is a vertical stretch by a factor of 3, a reflection in the x-axis, and a translation 2 units left and 2 units up of the graph of f. Consider the function g of x equals -3 times the quantity x plus 2 squared plus 2. Graph f of x equals g of the quantity x minus 4. Notice that the function f is of the form y equals g of the quantity x minus h, where h equals 4. So the graph of f is a horizontal translation 4 units right of the graph of g. To graph f, add 4 to the x-coordinates of the points on the graph of g. So the point negative 2, 2 becomes the point 2, 2. The point negative 3, 0 becomes the point 1, 0. And the point negative 4, negative 8 becomes the point 0, negative 8. Water fountains are usually designed to give a specific visual effect. For example, the water fountain shown consists of streams of water that are shaped like parabolas. Notice how the streams are designed to land on the underwater spotlights. Write and graph a quadratic function that models the path of a stream of water with a maximum height of 4 feet represented by a vertex of 3, 4, landing on a spotlight 6 feet from the water jet, represented by 6, 0. To solve this problem, use the given points and the vertex form to write a quadratic function, then graph the function. The vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k. You are told that the vertex hk is 3, 4. So substitute 3 for h and 4 for k. Now use the point 6, 0 to find the value of a by substituting 6 for x and 0 for f of x. 6 minus 3 is 3, and 3 squared is 9. So you have 0 equals 9a plus 4. To solve for a, first subtract 4 from each side, giving you negative 4 equals 9a. Then divide each side by 9, leaving you with negative 4 ninths equals a. So f of x equals negative 4 ninths times the quantity x minus 3 squared plus 4 models the path of a stream of water. Now graph the function. Because h equals 3, the axis of symmetry is x equals 3. So to graph the function, you first want to graph the axis of symmetry along the line x equals 3. Then plot the vertex 3, 4. Now you want to find and plot 2 more points on the graph. Because the x-axis represents the water surface, the graph should only contain points with non-negative values of f of x. You know that 6, 0 is on the graph. To find another point, choose an x value between x equals 3 and x equals 6, then find the corresponding value of f of x. When x equals 4 and 5 tenths, f of 4 and 5 tenths equals negative 4 ninths times the quantity 4 and 5 tenths minus 3 squared plus 4, which simplifies to 3. So plot the point 4 and 5 tenths, 3. Now reflect these points in the axis of symmetry. So plot 0, 0 and 1 and 5 tenths, 3. Then draw a smooth curve through the points.